Okay, we're going to find all the possible rational zeros to the following polynomial function. 2x cubed minus 5x squared minus 6x plus 4 equals 0. So the first thing that I'm going to do is I'm going to use the rational zero theorem to list all the possible rational zeros. So according to the rational zero theorem, we take the factors of the constant, and the constant here is 4. And so the factors of 4 are 1, 2, and 4. Then I'm going to take the factors of the leading coefficient here, which is 2. So the factors of 2 are 1 and 2. So this here, the 4, represents the p, which is the factors of the constant. And the 2 represents the q, which is the factors of the leading coefficient. So the next thing I need to do is I need to list all the possible rational zeros. So I'm going to do plus or minus p divided by q. So for this particular problem, it is plus or minus 1 over 1, plus or minus 1 over 2. So I take each p number and divide it by each q number. So my next p number is 2. So I'm going to do plus or minus 2 over 1, plus or minus 2 over 2. My next p-value is 4, so I'm going to do plus or minus 4 over 1, plus or minus 4 over 2. Then what I need to do is reduce them, and if I have them written down once, I don't need to write them down again. So my possible rational zeros are plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 2 over 2 reduces to 1, so I already have that, I don't need to write it again, plus or minus 4, and plus or minus 4 over 2 reduces to 2, so I don't need to write it again. So these are my possible rational zeros. So plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus 4. Now, what I'm going to do next is I'm going to use synthetic division to determine which one of those possible rational zeros is a rational zero. So my polynomial function was, again, 2x cubed minus 5x squared minus 6x plus 4. And I'm going to do synthetic division to test these. So they were, if I remember right, plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus 4. So if I go back here, those were my possible rational zeros. So I'm going to just start here at the top here. So my first number that I'm going to test is 1. So in synthetic division, what I do is I write the coefficients of my polynomial down. So 2, negative 5, negative 6, and 4. I'm not missing any of them because it's going x cubed, x squared, x, and my constant. If I was missing a term, I'd have to fill it in with a 0. So my first number I'm going to test is positive 1. So I put a 1 outside here. My first number comes straight down. And then I multiply. 1 times 2 is 2. I add here. Negative 5 plus 2 is negative 3. I multiply. 1 times negative 3 is negative 3. I add here. Negative 6 and negative 3 make negative 9. I multiply. 1 times negative 9 is negative 9. I add 4 and negative 9 make negative 5. This is my remainder. It is not 0. So that means that 1 is not a possible rational zero. So I'm just going to go through the list here. So my next one that I'm going to guess is negative 1. So I try this again. 2, negative 5, negative 6, 4. Again, bring down the numbers 2. Multiply. Negative 1 times 2 is negative 2. Add, you get negative 7. Negative 1 times negative 7 is 7. Add, I get 1. Multiply. Negative 1 times 1 is negative 1. Add, I get 3. Again, the remainder is not 0, so that one does not work. So I try again. This one time I'm going to try a half. So again, 2, negative 5, negative 6, and 4. First number comes straight down. A half times 2 is 1. Add, I get negative 4. Half of negative 4 is negative 2. Add, I get negative 8. Half of -8 is -4. My remainder is 0. So this is the one that I want. So 1/2 is my possible rational 0. Now, this can be very, very time consuming. So another way that I could do this is I could graph this function. So I'm going to open up Desmos, which is a online graphing calculator, and I'm going to actually graph this. So I've already typed it in, 2x cubed minus 5x squared minus 6x plus 4, and this is the graph that I'm seeing. Notice that this graph is showing that it crosses the x-axis in 3 places. And if I can zoom in on it, and show you, here are the 3 x-intercepts. And I'm just going to touch on them, and this one's -1.236. Now that's a rounded answer. 0.5, which is a half, and 3.236, which is another rounded answer. So the only nice decimal that I have here, or integer value, if it's not a decimal, is the half. So a half, I just showed you, was one of my rational zeros. So this also is showing me that because these are not what I would consider nice decimals, and it looks like they are rounded. So these are my irrational zeros. These would not be on that list. Plus, if I look on my list that I had, those decimals are not one of these numbers that I had listed out here. So I know that those are not rational zeros. Those would be irrational zeros. So my only true answer here is a half. Now what I'm going to do is I'm going to take this polynomial function right here. We call this our reduced function. And I'm going to use this and do the quadratic formula to find my other zero. So since this started off to be an x cubed function, this right here is representing 2x squared minus 4x minus 8. So I'm going to go to the next slide here, and I'm going to apply the quadratic formula. So 2x squared minus 4x minus 8. 2x squared minus 4x minus 8. The quadratic formula here is -b plus or minus the square root of b squared minus 4ac all over 2a. So subbing in here, -b would be +4 plus or minus b squared is 16 minus 4 times a is 2 times c is -8 all over 2 times 2. So solving inside my radical here, I have 4 plus or minus the square root of 16. 4 times 2 is 8. 8 times 8 is 64. This goes to a plus 64. And then on the bottom, 2 times 2 is 4. So I have 4 plus or minus 16 plus 64 is 80. All over 4. Now, what I need to do is I need to simplify that square root of 80. So square root of 80 simplifies to square root of 16 and square root of 5, which is 4 radical 5. So my quadratic formula becomes 4 plus or minus 4 square root of 5 all over 4. Then because, let me show you, because this number, and this number all divide by 4, this will reduce to 1 plus or minus 1 square root of 5 all over 1. So if I wanted to figure out what this decimal is, 1 plus the square root of 5 is 1 plus square root of 5 is approximately 2.24. So 1 plus the square root of 5 is 3.236. And 1 minus the square root of 5 is -1.236. And if you remember, those are where it crossed the x-axis. So my zeros are, it has 3 real zeros. They are a half, 1 plus the square root of 5, and 1 minus the square root of 5.